Robbie was frustrated. The Adams exam was in a few days, and if he didn't pass, then he wouldn't pass chemistry class. No matter how hard he studied, he felt like he just wasn't getting the concept. Robbie's behavior caught the attention of his father, Robert, who was worried about his son. He confronted Rob about the issue and he assured him that he will help. He first started explaining what an atom was and how it related to an element. You see, Robbie, the first thing that you need to understand is what an atom is. An atom is a basic unit of matter, or the building block of life. Oh, I see. So everything that makes us and all matter around us is made up of atoms, replied Robbie. Yes, replied Robert. In fact, the relationship between an atom and an element is that atoms make up an element. Robbie was trying to put two and two together. But Dad, I don't understand elements. There's just so much of them. Don't worry, son, replied Robert. It will make more sense once you start small. Let's take the element bromine, for example. Okay, replied Robbie. The periodic table of elements is basically the table where all elements are organized based on their number of subatomic particles, said Robert. There are 3 subatomic particles, protons, neutrons, and electrons. Are they important? Asked Robbie. Yes, Robbie, very important and unique, replied his father. The protons, for example, have positive charges, the electrons have negative charges, and the neutrons have neutral charges. The mass of the neutrons and the protons are about the same, while the mass of the electrons are significantly less than the mass of the protons. Okay, said Robbie. Now remember how we are going to use the bromine as an example? Said his father. Well, bromine has 35 protons, 35 electrons, and 45 neutrons. But Dad, how do you find those numbers? That is what I was going to get to, replied his father. You see, the number of protons and electrons depends on the element's atomic number. It is found usually on the top of the element of the periodic table and is always a whole number. The atomic number of bromine, for example, is 35. Since elements are in neutral stage, protons with a positive charge and electrons with a negative charge make the atom neutral. Thus, the atomic number is both the number of protons and electrons in the atom. The neutron, on the other hand, is a little different. You see, just each element also has an atomic mass, which is basically the average mass of the atom in an element. It can be found under the element's chemical symbol. The atomic mass of bromine is 79.904. Using this number, one can find the number of neutrons in an element by rounding it to the nearest whole number and subtracting the atomic number from it. So for bromine, you would round the atomic mass up to 80 and subtract the atomic number 35 from it. This will give you 45 neutrons, right, Dad? Yes, Robbie. See, you are getting better at it. Now, on the periodic table of elements, each element has a chemical symbol. The chemical symbol of bromine is Br. If you look in the periodic table of elements, you should find the atomic number 35. The chemical symbol Br, the atomic weight or mass, 79.904 to find bromine, explained Robert. But how do you know more about the element other than just the table of elements? You see, son, replied Robert, the periodic table of elements tells us more. It is also organized in sections that categorize elements for their reactivity and types of metals. Bromine, for example, could be found in the halogens family, located in group 17 of the periodic table. We could go more into this, but you really need to know that for your test, Robbie. Okay, Dad, said Robbie, who was now excited to know more. But Daddy questioned, can we actually see bromine and other elements? Of course, replied Robert. They each have physical and chemical properties. For example, the physical properties of bromine is that it is a reddish-brown liquid at room temperature, can easily evaporate when it is in the right situation. Its boiling point is at 137.8 degrees Fahrenheit. Its melting point at 19 degrees Fahrenheit. One of its key properties is its odor or smell. In fact, the word bromine is derived from the Greek word bromis that defines to a really bad or horrible smell. Oh, that's real neat, replied Robbie. What about the chemical properties? The chemical properties are that bromine is a very reactive element, especially with metal like potassium. It is also very toxic and irritate the lungs and throat if one is exposed to it. Lastly, it dissolves well in organic liquids like ether and alcohol, and also combines with unreactive metals like platinum, explained Robert. Oh wow, we know a lot about these elements than what was on the periodic table, explained Robbie. If you think that's crazy, then wait until you learn about what bromine is used for, replied his father. Bromine has so many uses. The most known use is that it makes materials like clothing, carpets, drapes, and more flame resistant. To do this, chemists soak the materials in bromine compounds that coats the fibers and makes it less flammable. Other uses include making drilling wells more efficient, manufacturing pesticides that kill pests for farmers, water purification for swimming pools, organic synthesis, and making shrink-proof wool. Wow, it has so much uses that are helpful every day, said Robbie. True, replied Robert, but bromine is too reactive to exist freely in nature. Instead, it exists as chemical compounds that form with other elements. The two most known compounds of bromine are sodium bromide and potassium bromide. They have a number of uses that include playing a role in the extraction of bromide from the sea. But Dad, where can these compounds be found? Asked Robbie. Well, Robbie, they are found in underwater beds and seawater, specifically in the Dead Sea between Jordan and Palestine. Bromine, however, is extracted from the bromine-rich brines in the U.S., Palestine, and China. To extract it, chlorine is added to seawater that contains either one of the two compounds, sodium bromide or potassium bromide. Since chlorine is stronger than bromide, it replaces it in the chemical reaction. I'm so happy we have an animal like bromine, said Robbie. Without it, the world would be such a worse place. More fires can occur without the fire-resistant materials that are made because of bromine. Swimming pools can make people sick without purification, and it'll be harder to drill and mine. Yes, indeed, replied Robert. So do you understand atoms now? Yes, Dad, replied Robbie. Thank you so much. I'm going to pass this test. Also, guess what, Dad? I even learned a few more facts about bromine. It was found in 1825 by Antoine Jerome Ballard and Carl Jacob Lawig, but wasn't reproduced until the 1850s. Also, it's actually very common and has similar properties to iodine, chlorine, and fluoride. Lastly, it is one of the only liquid elements beside mercury and gallium, and only has two isotopes that are almost equal in quantities, bromine 79 and bromine 81. Wow, that's really unique, said Robert. Sure is, said Robbie.